Hello everyone. If you're interested in wildland fire science, I think you'll find this presentation really interesting. I'll be providing an overview of the DoD Wildland Fire Science Initiative's Collaborative Research Burn campaign at Fort Stewart, Georgia. My name's James Furman, and I'm really excited to share the details of this event. As you'll see later in the presentation, this event has the potential to shape the future direction of wildland fire science. So to start, we'll talk about the Wildland Fire Science Initiative, give a little bit of background and some definitions. Then I'll talk a little bit about Fort Stewart, just kind of where it is and what it is. Then we'll look at the type of things that were being measured during the collaborative research burns that were carried out there. Look at sort of the what, where, why. And then we'll take a look at some of the preliminary products and imagery that was produced from this research campaign. And the real neat thing about this research campaign was the VIP workshop that got integrated into that. And I'll spend a slide talking about that and some of the potential ramifications from that. Then I'll wrap up with an overview of the DoD Wildland Fire Science Initiative and some of the impacts that it has or that it could have moving forward. So some background definitions and acronym translations are in order here. DoD and the wildland fire science world both use a lot of acronyms, so I've limited the use of them where I can, but there are a few that you need to know. CERTIP and ESTCP are DoD environmental research programs. It's the Strategic Environmental Research Development Program and the Environmental Security Technology Certification Program. Also, I'd talk about the DoD Wildland Fire Science Initiative. The DoD has been investing pretty heavily in wildland fire research for the past 10 plus years, but specifically we'll be referring to the current suite of 12 wildland fire science related projects that are ongoing currently. There are a total of 11 CERTIP projects and one ESTCP project. We'll also talk about the Integrated Research Management Team, or the IRMT. And that's the ESTCP project designed to coordinate and support these 11 current CERTIP projects that comprise the DoD Wildland Fire Science Initiative. And that's also where I come in, as I'm actually the principal investigator for the Integrated Research Management Team. So a little bit about Fort Stewart is interesting. Fort Stewart was an especially busy place the first week of March when we were there for these collaborative burns, because that's the week that Russia invaded Ukraine and many of the troops were preparing to deploy, or actually were in the process of deploying. So the military folks at Fort Stewart were pretty distracted when we were there. In addition to the impressive and important military mission at Fort Stewart, they have what is likely the most productive prescribed fire program in the Western Hemisphere, perhaps in the known universe as far as that goes, averaging approximately 120,000 acres per year. So this is on an installation that's 273,000 acres. So they are really getting the fire on the landscape here. So with that amount of prescribed burning that's taking place, they've seen a 90% reduction in wildfires over the past 20 years and have not lost a single training day since the year 2000. So really, really successful high ops tempo prescribed fire program at Fort Stewart. So this was a great backdrop for the wildland fire research that was going on, as well as for the VIP workshop. So at Fort Stewart, we had 39 scientists from 9 different organizations and 10 of the 11 current CERTIP projects. There were 3 burn units that were completed during that week for a total of 2,890 acres. Also, this effort was supported by 8 integrated research management team members and certainly by the Fort Stewart staff, which was huge. So as far as the types of things that were being measured, on-site weather monitoring, pre and post-fire measurements. We had airborne and terrestrial LiDAR scans, ground-based GoPro imagery, as well as your traditional fuel sampling plots, clip plots, that sort of thing, fuel moistures, etc. So during the fires, actually had infrared and multispectral tower and aircraft imagery, including some from the Fireball system, which I'll show later on. Also had some satellite-based thermal imagery, measured ignition patterns and timing, total heat flux, spread rates and patterns. Also looked at smoke plume measurements, chemistry, particulate concentrations, ground-based LiDAR, several things, and we'll show those later in the presentation, but a lot of measurements taking place. So a little bit about where is measured. Well, Fort Stewart, for those that aren't familiar with it, is in southeast Georgia, about 30 miles west of Savannah, and there were a total of 3 units burned. If you look at the map here, you can see 2 units, the F6.3 and F6.4 up in the upper right-hand corner. Those were burned separately on the first 2 days of burning. Then we had a break and then burned the E units together as a single unit. So the Fireball sensor that I mentioned earlier was flown in a rotor wing aircraft, Bell 206, between 5,000 and 7,000 feet above ground level, and also received satellite imagery from GOES and the Sentinel-2B satellite. We had smoke sensors that were placed at varying distances downwind as well. This map illustrates how heavily instrumented the burn units were and some of the types of measurements that were being taken. Aerial ignition was used for all of the different burn blocks, and you can see the routes of the helicopter during the second day of burning. It's important to note that all measurements taken by all the different instruments were time synced. They used the same GPS projections and the same metadata standards. So this synchronization and standardization between all the participating projects significantly enhances the opportunity for inter-project collaboration and sets a very high bar for future collaborative research events. Let's talk a little bit about why it was being measured. So a primary focus is to gather data to evaluate and accelerate operational availability and use of the next generation physics-based fire and smoke behavior models. The images on the right are from a couple of previous CERTIP and ESTCP projects that have moved the ball forward on the use of physics-based fire models for fire managers. DoD considers climate change impacts, including wildfires, as challenges to military readiness and national defense in a larger sense. And so there's a high level of interest from DoD in wildland fire. So due to the nature of the DoD missions, DoD manages some of the most wildfire prone landscapes in the country. Munitions are exceptionally good fire starters. So DoD also supports some of the most productive prescribed fire programs in every region of the country. So here's an example of some images captured on the second day of burning. So this is the same unit that you saw the helicopter firing pattern on earlier. The high resolution thermal imagery captured by the Fireball instrument is truly unprecedented. The developer of this instrument said that this was its first fully successful deployment. In the Fireball image to the upper left, you can actually see the location of each individual fire started by the ignition spheres. The gaps you see in these early ignition lines coincide with the wetlands embedded in the unit. The IR data from the satellite, fireball, and on-the-ground instrumentation should provide robust data sets for comparison and calibration with the physics-based models that are being tested. The image in the lower left shows the temporary evolution of smoke plume structure, density, and height as measured by a ceilometer, which is a type of atmospheric LiDAR. And closer to the ground, we had tower-mounted cameras capturing both visible spectrum and infrared imagery, as you can see in these two images. These camera plots were co-located with many of the terrestrial LiDAR plots, providing a fine-scale connection between fuels and measured fire behavior under the specific weather conditions during the burns. To my knowledge, there has never been the intensity and diversity of cross-scale fire behavior measurements combined with 3D vegetation characterization. I mean, this includes from the millimeter scale all the way up to the satellite scale on a landscape scale fire. So this should provide a treasure trove of valuable data for connecting the energy release, both measured and modeled, to fire effects like scorch, top kill, and other related fire effects. This image, captured of the first research burn by the Sentinel-2B satellite, was apparently somewhat historic, as this satellite had only recently been put into service and come online. To capture this image of this particular burn, which has all of this other instrumentation in place, was a really big deal, according to one of the remote sensing experts that had come to Fort Stewart for the burns. So QuickFire is a next-generation physics-based fire behavior model developed in large part with funding from the DoD Wildland Fire Science Initiative that will run on a standard desktop computer. This is a QuickFire run for the first half of the March 2nd burn at Fort Stewart. This is the first effort to link the fuels, ignition pattern, winds, and wetlands into a retrospective simulation of the burn. It also leverages fast fuels, which was developed by one of the CERTA projects and co-funded by National Science Foundation's Wi-Fi Commons to construct high-resolution fuel beds. This cross-project and cross-institutional linkage is one of the integration outcomes from the DoD Wildland Fire Science Initiative that will likely have profound impacts on fire management for years to come. This is a great illustration of the value of collaborative, integrated research in creating management-relevant products. QuickFire generates a number of different products, including max power maps, as illustrated here. Also can generate smoke plumes, moisture loss across the stand, consumption estimates, and much more. Word about the planned activities at Fort Stewart created quite a buzz among key leaders in Washington. With coordination and leadership by Paul Stebline and Kevin Hires from the USGS and from Colin Hardy with CERTIP ESTCP, a workshop was facilitated at Fort Stewart with the collaborative research burns as an integrated feature and an example of the potential direction for future wildland fire research. The attendee list reads like a who's who in wildland fire and fire science leadership. It seems that being exposed firsthand to the most productive prescribed fire program in North America provided a window into what could be possible on so many other landscapes where agencies are struggling to meet prescribed fire targets. To gain a more comprehensive understanding of the various scientific objectives, the attendees received briefings in the field from principal investigators for the different representative CERTA projects. To wrap up, I'd like to take a step back from the specific burns at Fort Stewart and talk a little bit about the broader impact of the DoD Wildland Fire Science Initiative. For those that have the PowerPoint version of this presentation and would like to take a deeper dive, the links will provide additional information on each of the subject areas. Of course, a Google search will also work for most of them. So we've talked a little bit about quick fire and fast fuels. The animation here that illustrates, let me get that running for you. Okay, so the animation here illustrates a fast fuels data tile that shows the forest structure and takes into account topography. Different colors represent different species. This fuels data layer is now available in the lower 48 states via Landfire and is designed for easy ingestion into the new physics-based models. So BurnPro 3D is the Wi-Fi Commons project funded by the National Science Foundation I mentioned earlier that's using fast fuels and quickfire to develop a planning tool for prescribed fire managers. Wi-Fi Commons involves many of the same scientists as the Wildland Fire Science Initiative, so there's built-in synergy between these important wildland fire science initiatives. With increased emphasis on accelerating prescribed fire across the country, many believe that prescribed fire science is an idea whose time has come, and the article at the link makes a very good case for the concept. The Wildland Fire Science Initiative Overview link is a pre-recorded presentation that I gave to the National Military Fish and Wildlife Association last year, and I uploaded it to YouTube. If you're interested in this presentation on YouTube and would like to see this Wildland Fire Science Initiative presentation, my contact information is on the next slide. Feel free to contact me and I'll be happy to send you the link. I'd like to start by saying thanks to the CERDP ESTCP program leadership for having the vision and providing the funding that made this entire effort possible, and to all the scientists that work so seamlessly together for the greater good. Special thanks goes to the Fort Stewart Forestry Branch, including Brian Whitmore, Jeff Mangan, Curtis Bryant, and all the others that helped facilitate this endeavor. Your Southern hospitality was on full display, and we definitely couldn't have done it without you. I'd also like to thank Colin Hardy, Kevin Hires, and Paul Stebline for organizing and managing the VIP workshop and integrating it so seamlessly into the overall operations. This was huge and provided an extra dimension to the impacts from this event. Mary Neil Armstrong with the Southern Fire Exchange did a fantastic job capturing footage and documenting the overall event, for which we are all thankful. Products including podcasts and a documentary are expected out this summer, so definitely keep an eye out for that. And last but certainly not least, I'd like to thank the members of the Integrated Research Management team that not only made this happen, but also made it fun. In no particular order, thanks to Sue Wilder, Dexter Strother, Matt Snyder, Tommy Hawkins, Troy Floyd, Joe O'Brien, Rick Anderson, and Linda Chappell. Thanks for listening, and please feel free to reach out to me if you have any questions.